Okay, let's see what we got. Excellent. Yep. Okay, so Javier, go back and let's
Yeah, I know
just,
what I messed up.
did you figure it out?
Yeah.
Okay. What did you do wrong? Do you know?
Yeah. I put a plus instead of a minus on
Oh,
0.5. Yeah.
okay. Okay, good. And that, you know what, that's all part of the process is being able to look and go, oh, I misread the formula. And a lot of times somebody will have it in their notes incorrectly and then they get it wrong. And then once they figure out what they did wrong, then you can fix it. And I bet you never do that again. It definitely makes you stop and think about it. Okay, so for cost of 21, you should have gotten 2739.50 minus 2700, the cost at 20. So your difference and exact cost is 39.50. Good. Okay. All right. Any questions on that? We all good? Okay, now do your marginal. Okay, so marginal, which is approximate, means you're going to find the derivative of the previous. So one less. So go ahead and do that one. And then in the chat, put your answer. And it should be real close to 39.50. So that's what you should be doing. Good, Brian. Good, Cassandra. See, Orlin, looks like you got it. Let a few more people be done. Good, Amaya. Okay, so as we're walking through this, remember we're looking for marginal to approximate. So again, this term approximate has to be there for you to do this technique. Okay, use the marginal cost to approximate. So we're going to find the derivative. So the derivative of the cost function would have been 60 minus, and then the 2 times 0.5 is 1. So minus x. So we end up with 60 minus 20 which is 40. Okay, so how our costs are changing is approximately 40 on the 20, or our costs are increasing on the 21st food processor. Okay, so that's how our cost is changing. It's increasing by $40 when there's 21 food processors done. Okay, any questions on those? Okay,
No.
and so, oh, go ahead.
No, we're good.
Okay, all right. Oh, everyone's letting Javier answer for them. Okay, next one. Now we're doing average. Okay, so remember, anytime you're finding average, you're taking whatever function it is and dividing by x. That's how you're going to find average. Okay, so again, learn to read the instructions, and man, it makes a big difference. And then once you find the average, then you'll plug in 250. So this one, you don't need to change the numbers. Okay, you just plug the original number in. So go ahead and do A. And then in the chat, go ahead and write once you plug in the 250, what is your final answer? And there's 13 of us in here today, so I should get 13 answers. Because math, you can't just watch it. You have to actually do it to really understand it. Okay, so far so good. Very good. Okay, so here we go. So with this one, when you plug in 250, so it's going to be 40,000 times 250 to the -1 plus 300. So all of you are absolutely right, 460. All right, what does that mean?
Cost per unit.
The average cost per unit, because one might be 500 and another might be 200. So the average is going to be right kind of in between. It's kind of the median or the middle number. Okay, all right, so we're good there. So B, now we're finding marginal cost or marginal average. Okay, so what that means is you're going to take and find the derivative of the average cost function. That's what that means. Find the derivative of the average cost function. So again, this is just notation, just makes it much easier to write it out. So you have your average cost. And to do the marginal average, we're going to take the derivative of the average. So that -1 goes to the front. And then we're going to subtract 1. So we end up at -2. And the 300 goes to 0, right? That just drops off. Okay. So now you're set. Now you have your marginal average cost. And now you can find out what it costs with 250. How is it changing? So go ahead and do that and then plug it into the chat. And as you get the number, see if you can kind of put it into words in your own mind, what that number means. Okay, what do we got? Okay, so far so good. Great. Okay, you guys are doing the math perfectly. All right, now explain your answer. So you get -0.64. What the heck does that mean?
It means that for the first 250 units, they cost lower 0.64
Okay,
dollar.
good. Yes. So that's that, remember, calculus is all about instantaneous rate of change. So at 250 units, our average cost is dropping by 64 cents per unit. Okay, so again, that's going to be how on the test, how you guys are going to be able to get extra credit is you're going to be able to do the math, show me the math, and then for extra credit, you're going to give me an answer of an interpretation. What do you think that means? Okay, so again, I mean, just so that you have it, if you guys go back and look at this, type it out. Okay, at 250 units, the average cost is decreasing by 64 cents per unit. Okay, now it'll change depending on how many units we use, right? And that's the power of these derivatives is I can put in 300, I can put in 500, I can put in all these different numbers to see how is my cost changing. Is my cost lowering even further, or is my cost increasing? Does it ever change to where it's a positive value? Okay, so you can kind of test out those values. Okay, and then C says, use the results from A and B to estimate the average cost per frame if 251 frames are produced. So what do you think you're going to have to do there? Any ideas? You're estimating when 251 are being produced. So what do you think would happen?
You do the same, but instead of 250, use 251.
Okay, so that's a good choice, right? You're looking at what's the average cost at 251. So we could do that here. But see how it says use the results from A and B? So I'm looking at this 460 and I'm looking at this negative 0.64. So this is the average cost of 250. This is how the average cost is changing at 250 units. So if I'm estimating, right, I'm making a good guess. Well, I have an average of 460 and it's going down 64 cents on my next unit. Okay, so this is the 250. This is the 251 is going down. So it's actually going to be 460 minus 0.64. So my 400 or my 250 first unit is going to have an average cost of 459.36. So you can use the information that you have to kind of estimate what the next one's going to be. Okay. All right, we got one more. And so again, this is one that you will see in my math lab. Okay, so they give you the price in dollars and the demand X for a particular clock radio are related by the expression X equals 300 minus 10P. So A says express the price P in terms of X. So all this means, this part right here, whenever it has a statement in terms of, that means the X is what has to be inside the function. So for A, all you're going to do is you're going to rewrite this solved for P. So when I solve for P, right, just your algebraic process, I'm going to subtract my 3,000. And then I'm going to divide off my negative 10. So I get the price is, so look at this right here. That right there, that X over 10 negative is the same as negative 1/10 X. So this is going to come up when you're doing derivatives. If you have a variable on top, just remember there's a assumed 1 right there. So I can rewrite this as 1/10 times X. It makes it much easier to work with. So I have a negative 1/10 times X plus 300, because the negative 3,000 divided by negative 10 is a positive 300. Okay, now I have the price, that's P, in terms of the demand X. So I've just rearranged it. That's all I had to do is just rearrange it. Okay, so this is A. This is your answer for A. And then B says, find the revenue function. Well, remember, revenue is the price times the number of items. Okay, well, we have the price is negative 1/10 X plus 300. And then the number is just X. Remember, X is always represents the number of items. So X is the number of clock radios. So my revenue function is X times negative 1/10 times X is negative 1/10 X squared plus 300X. So there's my revenue function for the sale of X clock radios. And then the domain, right, this is just a polynomial. So my domain is all variables, all reals. I can plug anything in for X. All right, and then C says, find the marginal revenue. Marginal means derivative. So all that means is I'm going to take my revenue function and I'm going to find the derivative of that. So 2 times negative 1/10 is a negative 2/10 x. And then 300x, the derivative is 300. So if I clean this up a little bit, negative 2/10 is negative 1/5 x plus 300. And then I want to know what's the marginal revenue at a production level of 2100 clocks. So I take out my x and I plug in 2100. And then I calculate. Okay, so I get a negative 120. So to interpret that, type it over here, so and then I'll pull it over. To interpret that, my revenue decreases by $120 when I produce the 2100 radios, clock radios. So that's not good, right? I want my revenue to increase. I don't want it to decrease. Okay, so anytime you have a negative revenue, marginal revenue, that means there's something wrong, right? You got to make some adjustments. So let's look and see what the adjustment would be if our revenue changed by negative 220, right? That's that interpretation of D. So D says interpret that. Anyone want to give it a shot? How would you interpret that?
Your revenue would decrease
when
you produce 2,600 clock radios.
Correct.
You would decrease by 220.
Correct. Yeah. So is that worse than when I have 2100?
Yeah.
It is worse, right? So again, business does not mean more is better is not always true in business. So if I were to do the same thing and I had the revenue at, let's say, 1,000, it would be negative 1/5 times 1,000 plus 300. Let's see what that would do. Well, look at there. Now my revenue is increasing. So I have an increase in revenue when I'm only doing 1,000. So do you see that there's something going on between 1,000 and 2,100 where my revenue it was going up and then it switched and was going down. So that's finding that sweet spot of where can I have the biggest impact where my revenue increases and doesn't decrease, because revenue is what comes in. So I want it to be increasing. Okay. All right. So let me just type this. And any questions? All right. Well, that's all I got for today. Remember on Monday, we'll do a review, but you guys should be reviewing all weekend long. You should go over all of your notes, go over review all of your homeworks, your quizzes, do the review that's in your module. On the test overview, there's a review and the solutions. Yeah, go ahead, Orlin.
The homework have unlimited questions that you can do, like you know,
No, the homework you have, yes. Did I change? I might have changed it. I used to only do 3 attempts, but I believe I changed it to unlimited.
and then my math lab
I'll
also
double
has
check.
some to practice, right? Just problems.
Yes. Yeah. Yeah. I will double check that. I did want to make sure that that's open for you guys so that you have unlimited access. Yeah, go ahead, George.
I was just wondering if we were reviewing in class.
Yes.
Have a nice one, miss.
Okay, thank you, Brian. Yeah,
Thank
so
you.
on Monday we'll do a review in class. We'll kind of look at the review and then I'll give you some more things to work on, more practice.
Okay, got it. Thank you,
Okay.
miss.
All right, thank you. Anything else? All right, I will see you guys on Tuesday. Have a great weekend. Adam, you good?